and today I'm going to prove the trigonometric limit theta approaches theorem, and 1 minus cosine theta over theta is equal to 0, and a bonus limit sine theta over theta as theta approaches 0 is equal to 1. Is equal to 1. Okay, we will get these two limits at the same time from a single picture. Okay, this is a unit circle and the radius is 1. So center here, this is the radius, that's equal to 1 or is equal to 1. And next is a very small angle. Let me draw a very small angle. Pretend this is small, coming angle, using a different color, for example black. So pretend that this is very small. Okay, and theta is very small, and the vertical length here is, this is the vertical length. Okay, yeah, vertical length, and sine theta numerically equal to, because the hypotenuse here is also r is equal to 1, yeah, also 1. So sine theta is opposite over r is equal to 1. So sine theta is just the opposite length. Let me call that a small length h. This is equal to numerically equal to 1 because h over 1 is sine theta. So I'm writing sine theta as just h. And here the cosine theta is this length, this bottom length. Mark this bottom length as for example b. B is very close to 1. Okay, so cosine theta is equal to, here the b, adjacent side over hypotenuse, so numerically equal to b, the length of the base of the triangle here, right angle triangle. Okay, so the 1 minus cosine theta or theta, and theta is equal to the arc length. Theta is equal to this arc length. Okay, this arc length. This arc length. This is numerically equal to theta because arc is equal to, angle is equal to arc by radius. So radius is 1. We are using this formula. Angle theta is equal to arc over radius. So arc is numerically equal to theta. Okay, s over 1. So theta is equal to s. So s can be written as theta numerically. Okay, s. Or let me interchange the positions of s and s is equal to theta. So when theta becomes small, here the arc length and the vertical height becomes resembling. Okay, when theta becomes infinitely small, there is no clear distinction between h and theta. So the h or sine theta is approximately theta when theta is small, very small. Okay, if you divided this relation by theta, you will get sine theta over theta is approximately 1 when theta is small. When theta becomes infinitely small, we can write the limit sine theta by theta is equal to 1, hence this limit. Okay, so let's move to the first limit we need to prove, 1 minus cosine theta over theta. Okay, before that, let me zoom this portion. This portion after zooming is, it looks like this: the vertical height h and the arc length this, and this distance in here is the 1 minus cosine theta, this distance, because the radius minus the b is the 1 minus cosine theta. Radius is 1, cosine theta is the length of b. So this length and this is theta. Both approaches 0, but the 1 minus cosine theta distance, according to this picture, this zoomed picture, quickly approaches or more rapidly approaches 0 as theta approaches to 0. Okay, so the ratio 1 minus cosine theta over theta geometrically approaches 0 very fast. Sorry, the 1 minus cosine theta approaches 0 very fast than the theta approaches 0. Okay, according to this geometry. That's why the theta approaches 0, 1 minus cosine theta over theta equal to 0. When theta becomes very small, this length approaches more quickly than the theta, the arc length. Okay, we can prove it algebraically by using the first limit. Yeah, the algebraic establishment is theta approaches 0, 1 minus cosine theta. This is a geometrical proof. Okay, multiplication with the conjugate factor, that's 1 plus cosine theta, to prove it algebraically. Okay, 1 plus cosine theta, this is cosine theta, so this becomes theta approaches 0. And let me erase this, continue here, let's continue here, limit theta approaches 0, 1 minus cosine theta, 1 minus cosine theta times 1 plus cosine theta becomes 1 minus cosine square theta over theta times 1 plus cosine theta. So it's equal to sine squared theta over theta times 1 plus cosine theta, as theta approaching 0, limit we can be rewritten as theta approaches 0, sine theta over theta times 1 by 1 plus cosine theta and times sine theta. Yeah, we are splitting the sine theta, sine squared theta as sine theta times sine theta. Okay, so the first factor here is 1 as theta approaches 0. Second factor is 0 over 1 plus 1, that's equal to 0. Hence, limit 1 minus cos theta over theta as theta approaches 0 is equal to 0 algebraically. Okay, yeah, thank you for watching. Bye.